Hello and good morning, everyone. Good attendance for 10 a.m. on a Monday. So welcome to the joint WebGL and glTF session at the Khronos Developer Day here at GDC 2018. Excited to be here, excited to see you all. The first part of the session will be on WebGL and why you should target it as your next deployment platform for your next game. My name is Ken Russell. This is James Darpinian. We are both on the WebGL team on Google Chrome. I am also the chair of the WebGL working group, so you can blame me for any bugs in the spec, etc. So just to get started and kick things off a little bit, to show you just, oh, by the way, all of these slides are already online, so you don't have to take any notes or take any pictures or anything. You just search for WebGL Wiki, scroll past Wikipedia because they're the #1 hit for basically every search on the internet, and then it's like the third, the Khronos public WebGL Wiki under presentations from recent conferences. The slides are already there. So just a few tiny little demos from recent months to whet your appetite. People are putting out all sorts of cool little web pages that use WebGL for some kind of visualization. Whether it's a tiny little maps-based game that was a maps experiment. Wait for it, wait for it. Come on, get over there. Yes. Or folks that are using some of the latest deployment technology to take existing C++ code bases and bring them to the web using MScript and WebAssembly. WebGL is the in-browser cross-platform graphics API that lets you deploy these kinds of experiences seamlessly to mobile devices, to desktop devices, everywhere. So, as in way of introduction, it's a built-in 3D graphics API in the browsers, and it's based on the industry standard OpenGL ES APIs. You really can nowadays implement your WebGL app on one device, and it will basically run everywhere. There's no installation step compared to any other platform that you know of, so it's really completely frictionless. You get a lot of eyeballs on your content if you can bring it to the web in some form or another, even if it's not the full thing, even if it's just a demo. And you've got a lot of options for deployment. I mean, as a web browser engineer, we will encourage you to please just put your stuff out there on the open web without a firewall or a login page. But if you feel that you need to do anything else, do things differently, you have the options of building progressive web applications that give you like an icon on a mobile device's home screen and behave pretty much like a native app that you would write for those platforms, except you don't have to write a native app. The browser takes care of the install for you. You can also use wrapper packages such as Electron and Cordova if you really, really feel that you need a native desktop application, but you don't want to write one for every platform. You can also write native applications for iOS and Android using WebView and navigate to your website that way. So you've got a lot of options, a lot of deployment options for your content. We can assert that we've got pretty high API quality. The WebGL 2 Conformance Suite has over 340,000 individual test cases that cover the entire API pretty rigorously. And we've implemented workarounds for literally hundreds of graphics driver bugs that ensure that you get consistent behavior of the API across operating systems, GPUs, and devices. WebGL version 1 supports OpenGL ES2, not the newest graphics technology in the world, but people have done remarkable things with it. ShaderToy was built on OpenGL ES2. Nobody knew that you could do that kind of stuff with that class of API until the hackers came out of the woodwork and started showing the world on the web what you could do with it. This version of the API has like a 98% support rate. So you can be well confident that if you put out a WebGL version 1 web page, your app is going to run everywhere, and you're going to get billions of potential people looking at it. WebGL version 2 implements the ES3 API set. Currently, Firefox and Chrome support it. Edge and Safari intend to support it, and we are working with them to be able to do so. And the support rate, thanks to Florian Busch's WebGLstats.com website, is about 41% and increasing. WebGL 2's got all the features from OpenGL ES3, and you can do a lot of neat stuff with it. Now, a really fantastic marriage is WebGL plus glTF. glTF, the OpenGL transfer format, was designed with WebGL in mind, and thanks to lots of colleagues, has taken an amazing evolutionary step. So now it's now a physically based rendering file format. It's really interchangeable between a lot of tools. They have a lot of interesting stuff to tell in the second half of the session. The combination of these two technologies streamlines content authoring and delivery. You can deliver glTF 2 in the browser, and you can produce glTF version 2 from every modeling package nowadays, or a substantial fraction. Patrick and company will tell you about it. Two of the major WebGL libraries, 3.js and Babylon.js, already support loading glTF version 2, and you can just get stuff running very easily. Another new interesting technology is WebAssembly. Don't know if any of you have heard of it, but it is an evolution of a tool chain called mscripton, which was developed some few years ago to be able to take large C++ code bases and bring them to the web with minimal porting effort. WebAssembly is a new file format that's supported in every major browser, and it gives you the instruction sets to be able to run these kinds of code bases fast. Okay, it has real 64-bit integers, for example, which JavaScript does not have, so there's no emulation of that. And so with this, you can bring substantial code bases to the web. So I'm going to hand the presentation over to my colleague James, and he's going to show you some of what you can do with WebGL and the web.
Hi, I'm James Darpinian, and I'm going to show you some cool demos. So this first thing here is it's a small engine designed for fast loading, and it works really well on the web because you can just visit a page and immediately see something cool.
So, yeah, there you go.
Yeah. This fun demo here. This one, particle system.
I think that one's using transform feedback.
Is it actually using transform feedback? It might be. I like this one because it shows you can do actual non-graphical computations, physics. So fast loading is great. If you need a more heavyweight engine, Unity and Unreal both support WebAssembly export with WebGL graphics. And we have a lot of interesting demos there. So here's a demo of Unity's fancy high dynamic range rendering. Looks pretty nice, the bloom effect. We've got Unreal running here. I believe you said this was originally designed for the metal rendering API,
Yep.
and we've got it running in WebGL with WebAssembly. So WebAssembly, as Ken said, gives you all the benefits of C++, strong type system. What else do we do in here? We've got the... All right. You can see some pretty nice graphics. So in a lot of cases, it's a one-click export, so try it out on your game and see how it works. PlayCanvas is an engine that was developed in JavaScript. It also has a small download size, fast loading, and there's some interesting demos that we've got here. Oh, here's the editor. There we go. It looks a lot like Unity, but it's on the web. And actually, this demonstrates that WebGL is pretty great for tooling. Even if you're not shipping a game with WebGL, it can be great for tooling development. You get all the benefits of web deployment. Everyone's running the same version all the time. People can collaborate potentially. And it's powerful. You get a lot of great you can build your UI in HTML, and you have a lot of flexibility there. Okay. Babylon.js is an engine that has some pretty neat demos here. So this is a demo of transform feedback particles. It's WebGL 2 feature. And you can see the code here. Let's see. Oh no.
Try reloading.
Is the internet working? Let's see.
Is the internet working? We shouldn't have loaded all the demos at once. That was a mistake. We couldn't rely on the internet, and all right. No? Yes? Maybe?
Seems like the internet isn't working there. Actually,
Yeah,
let me
working.
try the other instance. There we go. So Uber has made a data visualization toolkit in WebGL, which is very fancy. It's got a lot of great features. Map-centric, but it also has some really fancy rendering features. It also has a transform feedback particle implementation, which I believe is, this is an instancing demo, but also cool. Oh yeah, here's the transform feedback one. A lot of particles here. This is a wind map of the entire US, and they've just added a particle system to visualize it. There's something crazy going on down here. What's that? Forge.
What's the other tabs?
Yeah. I had all these loaded in the other instance, but so Autodesk has this interesting CAD visualization tool, and they've got some fancy rendering here, so you can see translucency, and there's an explode mode. You can click on all the parts and see what they've got in them. It's nice just to be able to plop some HTML right on top of your rendering. Really nice, easy UI development there. And we've got some fun demos here. Seem to be loading pretty quickly, actually. It's a demo of some nice animation. This is actually a VR demo, which you can use with the VR headset, but it also works 2 dimensions.
Try to turn the volume up.
Is the sound actually connected? They've actually got some neat squash and stretch in this animation. It's hard. High quality. Anyway. Some fancy lighting effects. I only load a couple of these. We don't have to wait. This is a global illumination demo. So you can do some pretty fancy global illumination effects. High dynamic range. Water simulation with caustics. This one's fun. So as you can see, people are doing some pretty nice things with WebGL. And yeah, you can use it for all your games and tools. We've got a bunch of useful links here, which you can get in the copy of the presentation that's online. So again, that's on the Khronos Wiki. I think that's it. If you have any questions, feel free to come up to the mics, and we'll answer.
So, please.
Hi, I'm Eric Chadwick from Wayfair, and I was wondering if anybody has done any conversions from V-Ray and 3ds Max into WebGL Right now I'm investigating that kind of stuff and just interested to see if there's anybody that's doing something similar.
That's a good question. I mean, there's some rudimentary path tracing stuff being done on the web. I mean, it's not maybe fair to say rudimentary, but
yeah, I know it's going to be lossy, right? I just want to get out from V-Ray to PBR, and I know I'm going to lose some stuff, but just curious if anybody else is doing something similar. Thanks.
Why don't you stick around at the end, and maybe certainly stick around for the glTF portion of the presentation. Don't know off the top of my head though. So, the big takeaway is that we fix the driver bugs so you don't have to.
Hi, guys.
Hi.
What are the sort of performance losses from moving into WebAssembly versus if I was just running it natively?
I mean, that's a good question. The CPU-bound work is pretty comparable. In fairness, we do have some overhead in draw call issuing from the browser out to to the actual OpenGL driver. And part of the reason for that is sandboxing, right? The browser has to be sandboxed. You cannot allow content to just come in and run rampant, right? There's a lot of bad actors out there. And the sandboxing comes at a cost, but we try to minimize it, and we have continued to try to minimize it over time. So I can't give you a concrete number of what fraction of draw calls you're going to be able to get from WebAssembly versus a native app. But if you were batching your draw calls anyway, you're going to get excellent performance. Uber's visualization framework in particular, they specifically, and you can read all their white papers online. They try to make all their visualizations happen in one draw call. They set up, their index and other vertex attributes very, very carefully. Use instancing and other techniques, even transform feedback sometimes, to run one thing and compute what they're going to draw for the next draw call. But they leave all the stuff on the GPU, and they do maybe 2 draw calls per frame. And that's how you get excellent performance across all web browsers. On the web. And frankly, it's how you get good native performance too. It's just like when you're running a native app, you have more leeway in ability to do sort of a not great optimization job, and it still sort of runs fast, but you would actually get better performance if you did stuff like batching your draw calls. So we definitely recommend taking the time to think about how your data is organized in the GPU to minimize the number of draw calls. And if you do that, again, you're going to get excellent performance everywhere. Please.
There's some features I think that are missing from WebAssembly. They're working on adding, I believe SIMD is not yet supported, is that right?
Yeah, that's true.
SIMD and I think multi-threading is still a work in progress. So those are coming though, they're working on it.
Any looks for moving towards the Vulkan sort of style implementation, or where command buffers and things like that?
And we'd be happy to talk with you more about it after this presentation.
Thanks, guys.
I wanted to ask about the threading. So are you still bound by the browser only having one thread per process in WebGL? And what would be the timeline for us to be able to get more than that? Or what are your suggestions for kind of living with that reality?
Are you talking about in the WebAssembly environment, or are you talking about in the browser, like JavaScript environment?
WebAssembly, and then specifically I'm working in Unity, so it's kind of more from that perspective.
Yeah, as James mentioned, it's being worked on actively. The fundamental primitive or building block is called shared array buffer, and that allows multiple native threads inside the browser to look at the same view of memory. That's the C memory model, basically, C++ memory model. And unfortunately, many of you probably know that there was a massive security vulnerability discovered in basically every processor in existence called Spectre and Meltdown, where the speculation hardware in the chip can be used as a side channel attack to see data that you're not supposed to be able to see. And so all the browsers basically had to shut down the shared array buffer feature immediately, because unfortunately it could be used to reconstruct very high precision timing to be able to measure clock cycles very accurately and thereby figure out, ooh, am I in the cache? Am I hitting main memory? Am I and then basically exfiltrate data that they weren't supposed to be able to. Now, all the browsers are also working on mitigations for this, and they all anticipate turning that feature back on. And the minute that that feature is turned back on, hopefully in a matter of months, then threading will basically come with it in the WebAssembly environment. But it's the primitive that's required. So all of us were really hoping to have threading out, and then this massive meltdown happened in the industry, and we'll all get past it to the point where it's turned on. And I would say months, certainly not years.
Maybe talk about off-screen canvas.
Yes. Would you like?
I don't know that much about it.
Okay. One other thing to mention in the threading world is that even in JavaScript right now, and in I'm not sure whether the Unity and Unreal Engine exports have a mode for this, but you can move the work of the engine off the main thread onto a background thread. And even though it's still single-threaded there, it's pushing the frames over to the main thread. And at least you get a little bit better parallelism between that and the rest of the browser work. So hopefully, like eliminating hitching, that's really the goal, all of our goals, whether it's our native engines or on the web. And that's possible to do. We probably need to partner a little bit better with Unity and Epic Games to ensure that that mode works well, because it really does provide some tangible benefits to like smoothness of your content.
Right. Layout, HTML layout won't block your game or anything like that.
Yeah.
Hi. In order to do high-performance VR rendering with WebGL, we really need the features of OpenGL ES2. Is there a roadmap to get there so we can do index rendering with render targets that we can specify?
So we should ask specifically. I'd love to talk to you after the session to find out exactly what features you need. Because ES 3.2 is hard to reach portably. That feature target is difficult. ES 3.1 is more tractable, and we're looking at concrete sub-features of ES 3.1 to bring to WebGL as extensions to, basically to raise the ceiling on what kind of content you can build. But I'd like to know specifically what features you need from ES 3.2, because you can already do multiple render targets and other things in ES 3.0 and in WebGL 2. But if there are concrete things missing, we'd like to know.
Hi. Have you found that either with like Unity or Unreal, the fact that the engine is kind of large and requires a heavy download right at the beginning, that's a big barrier to entry for WebGL for some of these developers?
Yes.
Yeah. Okay. And I guess more just kind of curious if there was any mitigating advice that you guys had.
I recommend PlayCanvas. They have a 250 kilobyte download size and a full-featured engine and online collaborative editor. And I'm not paid by PlayCanvas either. I think they've got some great technology.
Awesome, thank you.
I also think that you should watch for announcements from both Unity and Epic Games in that realm.
Great, thank you.
All right, so we should probably wrap up and hand it off to Joseph. Thank you, and please stick around at the end of the session. Love to talk to you all. Okay.
So my name is Patrick Cozzi. I'm from the Cesium team, and I also chair the 3D formats group with Khronos. So I want to give you some quick glTF updates before we get into the speakers with all the exciting work they have. Before I start, other than Ken's intro, how many people already heard of glTF? Cool, about half, about 2/3, cool. Okay, so glTF is open standard runtime 3D format. You can think of it like the JPEG for 3D. And I still remember the very early days of glTF, where it was in the Cesium engine, it was in a demo that Brandon Jones here implemented, and it was in a Colada the glTF converter. And I am humbled and thrilled to share the news with you that we have today when you look at how that ecosystem has grown tremendously. So some of the highlights we want to share is, and this is for the first time being announced, that Unity has joined the open source effort that Microsoft started for the Unity glTF importer and exporter. So thanks to Tony Parisi and Unity for that big contribution. And they plan to have that packaged by end of the year. Unreal also has experimental glTF import. That's all I'm going to say about that, because we have Mike Erwin from Epic Games to talk more about that today. Facebook, drag and drop your GLB files to do 3D on the web. I think it's great for bringing 3D to the masses with Facebook, but it's also pulling through exporter and conversion ecosystem. So you see Facebook putting out an FBX to glTF converter, then other industry players like Modo adding glTF export in order to support content in Facebook. Sketchfab, amazing members of the WebGL community, giant 3D model repository, and there's 150,000 models in Sketchfab that are Creative Commons licensed and available under glTF. So glTF really making that content available is great. As the ecosystem grows and as people get more requirements, we really want to keep it robust. If someone exports a glTF model, we want to see that be able to be imported correctly. So we've been doing a lot of work in terms of providing tools and sample models so that if you're writing either an exporter or an importer, you could validate your export, or you have lots of sample models to check with your import. All this stuff is open source as well. The grassroots open source community continues to be there, even as big players adopt and big players contribute to that open source. And a theme that we'll see today, too, is that glTF has the roots in WebGL, but it's being used on desktop and across all graphics APIs. So just quick, you can see how the ecosystem has grown tremendously with all the exporters and converters, several model repositories, lots of runtime engines. And these slides will also be online on the Khronos website, but please keep taking pictures. It's cool. So glTF, though, we're a very open group. All the spec work is done on GitHub. We engage with the community every day. I'd love to get your feedback on the spec, potential extensions you would like. Also, love to hear about the work that you're doing, open source, even not open source. We'll shout it from the rooftops for you. So please contribute to the ecosystem, contribute to the spec. Also, joining Khronos is a great thing. So we really love the community around the project. And that's pretty much all I have to say before our speakers join us. And this is a glTF speed round, 5 minutes each. We have presenters from Epic, Adobe, Google, Microsoft, AMD. This is really, really amazing. And we're going to kick it off with Mike Erwin from Epic.
Thanks, Patrick. Hi there. We just came out with Unreal Engine 4.19 this past week. You can see a lot more about it on the show floor, but my little corner of this release was the new glTF support. And basically what we have so far, you can import static meshes, materials, textures, all into Unreal Engine, and they come in really smoothly. This first release is experimental, is what we're calling it, but it's in the main release. You can turn it on, try it now, and kind of this is a nice time to give feedback and say where are we going to go next, because there's lots of things, there's lots of directions we could go with this. Animation, of course, bringing in full scenes instead of meshes at a time, things like that. And so I'd love to hear from people here and from people watching this, where's a good place or where your needs lie. So basically how this works is you fire up the editor. You have to enable the glTF importer because it is experimental and we don't want it to just always be there and breaking things and having a lot of questions unless you know what you're doing. And then from there, you just go to the content browser. You can click that import button. And in this example, we're bringing in a GLB, which is the binary format. It handles text, binary, all that. And this is one of the sample models that's up on GitHub. Actually, I believe it's the one that was shown on the previous slide. And from there, once you import it, it just brings everything in. You've got your mesh model there, you've got your material, your textures, everything just came in from that single file, which is a really simple workflow. And there it is, bam, in the engine. And what's really nice about glTF versus some other formats is it takes a lot of the guesswork out of the import process and out of the implementation of the importer. One big thing, of course, is coordinate systems. Everyone has their own, and there's Unreal in the corner kind of by itself. And so if you're exporting from Max or Maya or Blender or whatever, you know, getting that right is kind of a tricky thing. And experienced modelers and experienced artists or technical artists, they know the workarounds, they know what to do to set all this up. But with glTF, you don't need to know that. You don't need to run into these things because there's a standard orientation and scale. No matter which package you're exporting from, it's going to, once it's in the file, it's in that standard thing. And the importer for Unreal or for any other engine just knows what to do with that. And so everything is going to come in exactly like it was in your modeling program, right into the engine. And another thing that it takes the guesswork out of and just makes things work well is things like vertex normals, which surfaces are smooth, which edges are sharp and creased. And I made this example model when I was doing the implementation of the importer. You got the monkey head, I did a subdiv modifier on there, made some of the edges sharp, just to make sure all that would come over in the glTF. And what's nice about it is you can see this as a limitation of glTF. It's a delivery format. It loses the information of smoothing groups and all that. But what's really nice about that is that it gives you a really reliable, the final model. And there's no, basically when it comes time to import, there's no guesswork. The importer doesn't have to figure anything out or be clever. It just imports what's there, and it comes through fine. But of course, materials on these surfaces, that's where it gets nice and interesting. And we're using the metal roughness PBR that's built into glTF2. That's the only material model we're supporting right now because it's very close to what Unreal actually uses in the engine. And that comes with everything: normal maps, transparency, an emissive channel, baked occlusion maps. All this stuff just works right out of the box, and it's built into glTF, and it comes right into the engine. And it comes in as an editable node graph. So once you pull your materials in from glTF, you can tweak them, you can play around with them, you can add or enhance. You can have multiple materials per mesh. You can set those up in your modeling package, and those will come through just fine. And in this example, this is another one of the sample models. This is the first one I used to get materials working, is the avocado. And in this case, it's one material, but you could have a separate material for the skin, for the avocado meat, and for the seed. And you can even you can have those as separate materials. Another thing you can do is you can just say, okay, these are nice, but these are just placeholders. I want to swap them out with kind of a full Unreal material with procedurals, maybe bring something over from Substance or something like that. And you can swap all those out once they're in the engine.
1 minute.
Okay, I better go fast. And here's the helmet model from before. And so it's got a pretty good rich material model. It can't handle everything. It's pretty much image-based. That's baked from your modeler, but it can handle a majority of needs. And the last thing I want to address here is why would you use glTF when making games. I mean, Unreal Editor is a desktop application, Mac, Windows, Linux, and isn't GLTF a web thing? And I like to think of it as it's more like the ping of 3D. And the ping format came out over 20 years ago now, basically as an alternative to existing image formats. But it wasn't just an alternative, it did a lot of things better. And I think that's what GLTF is doing for us. It gives really predictable import and export, saves artists a lot of time. Your models aren't going to come in sideways, or you don't have to worry about if you're modeling in centimeters, meters, whatever. It just comes in just fine. The material model is rich enough for most uses, and anything else you can just swap out from the engine. And also important, it's an open format. It's a public spec. It's not just published, it's actually discussed out in the open, and you can really get involved. And as an implementer, kind of having confidence that what we have is compliant. And it's got sample models, validators, so we can kind of make sure it works pretty well. And then anyone can implement. You don't have to work for a specific company. You don't have to have a licensing agreement or anything. You just dive in and do it. And but I'd love to hear from you guys about how it works out once you start using it and what's next. Here's my info email. I'm Danger Cobra M both on Twitter and on the Unreal Engine forums, and that's a good place to give feedback on this sort of thing. All right, thanks.
Really awesome. Thanks, Mike. And next up, we have the other Mike from Adobe. The floor is yours.
Thank you. Good morning. So I'm Mike Bond from Adobe. I work on the Adobe Dimension team, and I'm going to talk about our efforts with GLTF and intentions. So to start with, I'll give you a quick rundown of Dimension. The Adobe Dimension's primary goal is to introduce graphic designers to the power of 3D with really easy to use tools. It's a relatively new product. We just launched version 1 in October. And since then, lots of people have been using it for streamlining their workflows and creating amazing artwork. So we're not targeting 3D experts. We're building products and services for designers, people who are already familiar with our flagship products like Illustrator, Photoshop, and InDesign. They're experts at working with 2D, and with Dimension, they can easily bring in their designs and iterate on them quickly and bring them to life in full 3D. It's really about democratizing 3D technology and making it easy for anyone to adopt. The usual workflow is the artist brings in their assets from Adobe Stock or wherever, and then they use our physically based material system in Dimension to set things up and getting it looking the way they want. They can add decals, they can bring in a background image, and Dimension will automatically analyze that background image, find the horizon line, use that to set up an image-based lighting map, set up shadows and reflections, and even the camera perspective to get your object looking like it's sitting on the the ground or whatever is in the image, basically aligning it with the horizon. And then usually they would export to a layered PSD file with a lot of information in it to do final like post-processing and stuff for their image. But soon they'll be able to make use of our GLTF publishing service, and this will allow artists to share their creations with the world, marketers to leverage interactive 3D on the web, that type of thing. And so I'll show you quickly just a quick demo of what it looks like when you export. Patrick, sorry. Yeah. Excellent. Okay. So this is that same Coke can, and it's using the Babylon JS runtime. And what you'll notice to begin with, it's nice and silky smooth. It looks okay, but it doesn't match. How do I bring this full screen in? Thank you. So you'll notice that it's missing the background. The lighting doesn't look quite right. The shadow, reflection on the ground. And this is because GLTF, as it's defined right now, is missing any environment information. It's kind of strictly the model format itself. And our goal is to make it so that somebody can export a scene from Dimension and have it look as close to as possible on the web or wherever they're exporting it to, look like it does in Dimension. So we've been working on pushing the glTF format forward with extensions. To start with, we've been helping out with the KHR lights extension, which allows the definition of simple lights in the scene. And we're going to be moving forward with hopefully getting environments, image-based lighting, and more advanced material features with translucency, and et cetera. And also, camera effects like depth of field. And now a lot of these extensions may end up being Adobe or Dimension specific, but as much as possible, we want to work with the community to get them to be widely adopted. And a lot of these are definitely not specific use cases, but very general purpose things. So yeah, there's going to be a pre-release version of Dimension available with glTF export sometime in April probably. If you're interested in it, just shoot me an email. I can get you on that list. There's a pre-release channel of Dimension available anyway, even now. And a quick shout out to the Microsoft guys. I've started using their glTF encoder and decoder, the C++ library that is cross-platform in the back end, and it's really helped clean up my code a lot. Has built-in validation and everything. Thank you.
Great stuff, Mike, and perfect timing as well, which is very much appreciated. Next up, we have Frank from Google, who's going to tell us about Draco mesh compression.
Hi, my name is Frank Galligan, and I'm the tech lead for Draco Technology. Draco Technology is a project that we use to compress and decompress multi-dimensional geometry. We open sourced it, the code and the bitstream specification under the Apache 2.0 license, which is a good license. Okay, a little history. We first released our technology in January of 2017, and we almost immediately started working with Khronos on adding it to glTF. And we just got ratified in February of 2018 as an official Khronos extension to glTF. This is a list of some models from the glTF 2.0 repository. Right here, we just collected data on the mesh data only. So you can see the compression rates. Personally, I might be a little biased, but I think they're pretty good. They do vary wildly depending on the input source. Also, the options that you give to the encoder can make the compression go up or down depending on what you do. One other thing is I don't have a demo showing it. I've been doing compression for about 20 years. Compression demos, they have either a picture or video side by side. They look exactly the same, and you say one is smaller. But otherwise, it's not very impressive. So this is a list of some of the tools that actually have a Draco glTF creation that are currently out there. Thanks to AMD and Facebook for writing some of the tools. And Simnio is actually a really cool tool. It's online. Import your model, and you can export it right there. These are some of the renderers that can actually do Draco glTF files today. Of course, 3JS and Babylon.js, PlayCanvas, which was mentioned earlier, Cesium, and some other native kind of engines have support as well. One thing I do want to mention is Khronos and us locked the extension to a specific bitstream version. This is very important for the community. So anyone can create Draco glTF files in any creation tool, take it somewhere else, it can render in any decoder, rendering engine, and it will work exactly the same. And extremely important for that interoperability. Okay, this is what we're working on today. There are a bunch of models out there now that have heavy animation. So if you just compress only the mesh part of that model, the overall compression rate, might be small. So we're actually working on compressing the animation in glTF files. We also, the actual technology, we do point cloud compression. We just didn't add that to the glTF file for time reasons. We wanted to get the mesh out first. So we're actually actively adding that to the glTF file format as well. And of course, we're always working on making the compression better. We do a lot of traditional research as well as machine learning to make the encoder much better. This is where you can go and get the code. We have C++ encoder decoder, as well as JavaScript and WebAssembly decoders, and actually encoders as well. We didn't list that. And if you have any questions or comments, we have our group, or just come find me. I'll be more than happy to ask or answer any questions you have. That's it. Great.
Frank, that was awesome stuff. And as an engine developer, I could have rolled my own mesh compression, but now I can utilize your 20 years of experience. So the power of standards, very, very nice. All right. All right, next up we have Tom from Microsoft to tell us about their work with glTF.
Yeah, hey everyone. So my name's Tom Mignone, and I'm a program manager at Microsoft, and I'm going to just show you a little bit about some of the work we've been doing in the glTF space. So starting out, we've got a lot of products that have already implemented 3D support, and really glTF is the backbone of what we're doing in a lot of those products. So whether it's creating a 3D creation for the first time in Paint 3D, or presenting a model in a meeting using PowerPoint, glTF is really just core to what we're doing in a lot of those products. Additionally, though, we're really committed to glTF as an open standard and kind of fostering that open source community through. Yeah, so you've already seen a couple of the projects pop up on different sides, but through our work with the glTF VS Code extension, some of the asset validators, it's really core to kind of retaining that quality in the ecosystem and pushing it forward. So I wanted to call out some of those projects. Today, though, I'm going to talk about some of the new features in the next update of Windows where you'll be seeing some of this pop up and just different product work. Now, if you're not familiar, this is a picture of the Windows Mixed Reality Home. So this ships with Windows 10, and it's the kind of home environment that users land in when they first put on one of the mixed reality headsets. You can kind of think of this like a desktop or your virtual desktop where you can launch and place apps. It's really your home environment before jumping into any games or app experiences. One of the first places where we took advantage of glTF was actually in enabling what we refer to as 3D launchers. So a developer can go and create this glTF model, assign it to their application, and then when users launch it from the start menu, they'll actually place that object in the world first. This is key for just kind of building up this virtual space model and letting people kind of customize their space in unique ways. But since we got there, and these are just really core glTF models, we wanted to explore just really how rich this could get. This is a sample model that we just uploaded to the glTF sample models repo, and I think it shows off just how advanced you can get with the PBR material model that's already there out of box. So the lighting looks great, and this is definitely a model you should pull down and check out in your own engines because it looks good in the environment. Now, for us, though, what was really important is users love customizing their space. So what glTF gives us is the ability to take models from a bunch of different resources and bring them into the world. So one thing we've also been working on is taking the collection of assets at remix3d.com and letting people pull those into their space. This will be coming out soon, but what we wanted to call out here is really this is all built on open APIs. So if you have a catalog of content or anything that's glTF based, you could use those APIs to bring content in as well. Now, One other announcement we had in the past was that you could export your Minecraft creations as GLTF models. So here you can kind of just see one of those Minecraft environments sitting in my world, which is great for kind of showing off your latest creations or showing off to your friends what you've built. But we really thought that you could do more. So one thing that we've been playing with here is that same Minecraft environment now replacing that cliff house or that home environment and becoming your entire world. What's really cool about this is just out of box, you can teleport around, you can place your apps and use it just like a home environment. But this isn't the Minecraft game, this is still just that home. It's basically now like my wallpaper for that environment. So it's really that flexibility to take GLTF and make it your entire world, but also populate it with objects that we're excited about, and it really opens up a lot of user-generated content possibilities. So this isn't available yet, but it's something that will be coming out here soon in an early preview state. So, you know, as you saw, we're using GLTF across the board. I didn't get to show some of the other products we've announced in the past, but really it is core to a lot of what we're doing, and we're making a big bet on it. It's given us a lot of interesting flexibility to bring content from a bunch of sources together across our different products. So this is just some of the work we've been doing. You saw that placemat at the beginning of a lot of the investments we're making, and we're excited to keep kind of pushing it forward. So if you have any questions, just catch us after the talk, but otherwise, thanks.
Thanks, Tommy. And Microsoft has really been a key part of the ecosystem, really helping drive things forward, especially in the world of PBR. Now, for our very last presenter, we have Dave from AMD, who's going to talk about what's going to be huge for GLTF, which is texture transmission. And we have exactly 5 minutes. Dave, you're out.
Good morning, everyone. Great to be here. So we're going to follow on a little bit from Frank's presentation for Draco. We have this issue where we've got a great transmission format with GLTF, a very efficient transmission of scene data. The trouble is when you get to binary assets, we need to be able to sort of get those across to the target device very quickly. So we're going to have some kind of compression. So why we call texture transmission rather than texture compression, that will become clear as I go through. Okay, so here's my whirlwind agenda because I have 5 minutes. So introduction to what we're doing. We've actually got a texture transmission task subgroup. So we have problems to solve which are going to take quite a few people to help us get to the correct solution. So we have a small group which we're looking to expand. That includes anyone here who is interested to help solve the problem of transmission of compressed texture data. So next thing, current methods for GPU texture compression and distribution. Texture compression for GPU is nothing new. But we need to think about it a little bit differently when we're talking about transmission from two different endpoints across, say, the internet or low bandwidth connections. And we're going to be introducing the universal format, which is something that we hope will be part of the solution, and I'll explain more about that soon. This whole thing is going to be an extension, and we're going to call this the KHR Texture Transmission Extension. Very early days, we haven't got any source samples or anything up on the repos yet, but keep your eyes on the Khronos webpage and you'll see more news as we develop that. Then we'll have a call to action. We want more people, and hopefully in this room there will be some volunteers, some people who are keen. Snacks and nap time, it's up to you. Okay. So the introduction to the text transmission TSG. Like I said, it's we can officially transmit the 3D scene data, but large assets are challenging. You cannot send JPEG or PNG as your texture assets across the wire. Most GPUs already have hardware block compressed textures, and you want to stick with those. We don't want to be decoding JPEGs or PNGs, on our target devices. But how do we transmit the text data via glTF in a way that all target hardware can use? There are so many different formats, GPU formats. The current design and the focus of this extension is around binomials basis solution, which, if you know of this from last year's GDC, very useful, very clever way of combining block texture formats into one universal texture format, which can be transcoded into any other GPU format. So top-tier IHVs, independent contributors are all working together on the solution. So a typical pipeline here is you'll have a texture tool workflow, original texture assets. Your tools pipeline will have to create a package for every single device that you have to support. Mobile A, mobile B, console, desktop. It's a lot of work, it's a lot of storage, and it's a lot of overhead. All GPU formats have common features. You can take advantage of those. So if you were to sort of reverse engineer all the differences between the different formats, you'll find a lot of commonality. So a universal format will just squeeze all those things together, and you'll be able to represent any texture format inside one big package. So this is the texture transmission extension, and this is called our universal format. And we do have one of these shipping with binomial basis right now. So as I say, the universal format representation can store any combination of GPU formats. To get them out, you use a transcoder. So that's not really a decompressor. There's a direct mapping from the universal format to any BC format or ASTC or EPC format of your choice. So this is what we're aiming for, universal format where you're able to transcode to any target device, whether it be mobile or desktop. So with our altered texture workflow universal format, original texture assets, a universal format encoder, one package comes out, which is a universal format which can be read by any device, mobile, desktop, of any level. So the KHR transmission texture extension, glTF authoring tools can import and export scenes with these compressed universal textures. So we will be able to provide universal formats with low precision, high precision versions with optional lossless encoding, LZE or ANS, to provide zip-style, JPEG-level extra compression on top of the universal format. All of this is open source, of course. This is glTF, so all this will be visible. And it also supports transmission of proprietary compression schemes, so you're not tied to our own universal format or encoders. Okay, call to action. We need more people, so we need more ideas. So please, if you're very interested in more about this, it's been very hard to explain in 5 minutes everything this extension does. Catch me after the talk. We're glad to go into detail. And there's some email details there, and email to Patrick, who runs the 3D Formats Working Group, if you want more info on how to join up. Thank you. Thank you, Erwin.
Thanks, Dave. I think Ken has some final words.
Please grab WebGL and glTF t-shirts outside.
Do we have time for questions or no?
We're pretty much out. Maybe one.
So we'll take one question, then any other questions just come up front. We'll all be here.
I'll ask one question. Hi. We are trying to take this format into enterprise landscape. And one of the areas we are trying to look into is how do you take enterprise-grade security and NFRs which apply to integrate enterprise solutions, such as, hey, what part of the avocado integrates with permission-based access? Is there a part of a specification that is working? How do you integrate into the enterprise kind of grade of security so you can?
So glTF doesn't have any permissions based into it. We have had some interest in people doing extensions for that,
Right.
But I haven't seen any significant work in that. I would be happy to connect you with that group, though, if you want to talk to them.
Thank you.
And if anyone has any more questions, please come up front. Thanks again for coming, and thanks again to the speakers.